Hello everyone. So today we are going to discuss the 23rd January second shift, which is the evening shift. Myself Prashant Khatri, and let's have a look at the first question. In photoelectric effect, an electromagnetic wave is incident on a metal surface and electrons are ejected from the surface, right? If the work function of the metal is given 2.14 electron volt and stopping potential is 2 volt, what is the wavelength of the electromagnetic wave, right? So, let us see that the function work function is given 2.14 electron volt, stopping potential is given as 2 volt. Okay. So, when I write down the equation, photoelectric effect equation, it is H C by lambda, which is equal to the work function plus the kinetic energy, right, maximum kinetic energy, and that Ke max is given by the stopping potential, which you simply do E into Vs, charge into stopping potential. So, you will write it down here E into Vs. Okay. Now, they are asking about this particular wavelength. Okay. Take the Hc value to be 1242 in the respective units, right. Let us write it down 1242 by lambda, work function is 2.14 plus what about electron volt energy for Ke max, it is 2 electron volt. So, this is lambda will be 1242 by 4.14 over here, right. So, this will give us the answer, this is 621,207, okay, and I think you can easily see 1 ja, this is like 300. So, this answer will be 300 nanometer over here. So, which option is matching at the end? Fourth option. Okay, so let us have a look at this question now, right. I can see that both the diodes over here are actually the forward biased. Can you see it? This is positive terminal side and this is the negative terminal side, correct. So, you can draw its equivalent circuit like this with a resistance of 20 ohm, resistance of 20 ohm, and then we have the battery of 5 volt. So, very simple now, these two resistance together will give me 10 ohm parallel combination, right, 20 into 20 by 20 plus 20, that is 10 ohm, and how much is battery voltage? 5 volt. So, what will be the current in the loop? The current will be I equal to delta V by R, which is 0.5 ampere. So, which option is matching over here? Fourth option. Okay. Let us move to the next one. In the next question, they are talking about using the PV diagram, work done by an ideal gas along the path ABCD. So, let us do it first along AB, A to B. How to find work? Work is nothing but area. Is A to B volume is increasing? Yes, I can see it there. So, work will be positive. Okay. And then B to C, what about B to C? Is the volume changing? No. So, in this process work done will be 0. And what about C to D? Work done will be negative. So, let us find it out one by one, but remember magnitude will be given by area under the curve. So, during A to B process, what work will be area? Which area? Over here, this one area, right. Let us find out this particular rectangle area. What is the length? It is P naught, and what is this breadth? It is V naught. So, work will be plus P naught V naught. Then from B to C work is 0, and then from C to D let us find out work, which is the area over there. So, with the which area? This portion area, right, this blue shaded area, and that area is simply what is the this particular length over here, this is 2 V naught and this length is 2 P naught, but it is negative because volume is decreasing. So, I will write down minus 2 P naught into 2 V naught. So, that is minus 4 P naught V naught. So, what is total work during the process A, B, C, D? It is going to be total how much? Minus 3 P naught V naught. That is my answer. So, which option is matching? It is the third option. Let us move to the next one. Two charges 7 microcoulomb minus 4 microcoulomb are placed at some particular positions, okay, and they have given the epsilon naught value also. Okay, the electrostatic potential energy of the charge configuration. What is the formula of electrostatic potential energy? K q1 q2 by r. Well, what is the r? It is the distance between 2 points. You will apply 2-point formula, distance formula for that. Okay, so that is nothing but root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, right? How much is x2 minus x1? 7 minus minus 7 will be 14, 14 whole square, then the rest is 0. So, it is nothing but 14 centimeter. Okay. And the k value you know already, it is going to be 9 into 10 to the power 9, q1 is given, q2 is given. Let us do it. So, how much is the potential energy? 9 into 10 to power 9, 7 into 10 to the power minus 6 multiplied by minus 4 into 10 to the power minus 6 divided by r 14 into 10 to power minus 2. Let us simplify it. 7 1 ja 7 2 2 1 2, okay. 9 2 ja 18 and 10 to the power 11, 11 minus 6 is 5 and then 5 minus 6 is minus 1. So, 18 into minus will be there, 18 into 10 to the power minus 1, this is minus 1.8 joule. So, that is the answer. So, which option is matching? It is the first option. All right, let us look at the next question. Okay. This is concave mirror of focal length f in air is dipped in a liquid of refractive index mu. Its focal length in the liquid will be, well, it is a conceptual question. Okay. What type of question? Conceptual, as you know that the focal length of the mirror is independent of medium, independent of surrounding medium. So, therefore, what is my answer? It is same as f, which is the fourth option. Let us move to the next one. The equation of transverse wave traveling along a string is given like this: y is equal to a sin o kx plus omega t. Okay. The velocity of the wave is, what is the velocity formula? Omega by k. What is omega? 600. What is k? 20 into 10 to the power minus 3. Done. But here x is in millimeter. So, my k will be unit what? Per millimeter. Remember this. So, this will give you answer in what terms? It will give you as the millimeter per second. Okay. So, this is nothing but 1 ja 3 30. So, 30 into 10 to the power 3 millimeter per second. So, in meter per second 30 meter per second. Which direction? This is speed. Which direction? See, this is kx plus omega t format inside that sine function, and whenever you have the coefficient of t and coefficient of x same sign, then it will be negative x direction. Therefore, if we write down velocity vector, negative x will be minus 30 I cap meter per second. So, which option will match? Plus 30 or minus 30? Minus 30. Okay. Let us move forward. A galvanometer having a coil resistance of 30 ohm need 20 milliampere of current for full scale deflection, right. So, you know the structure, you can think of it over here. You have to produce, you have to make the actually ammeter which can measure maximum current of 3 ampere, and they are asking what should be the shunt, right. So, let us see, you draw the structure first. This is a galvanometer Rg, and there over you have the shunt resistance S, correct. This structure is of the ammeter. So, here the current will be Ig and the remaining current here will be I minus Ig. I can easily write down Ig into Rg is I minus Ig into S. By the way, total I is here, right. Now, what is the value of Ig given? 20 milliampere. So, it will be written as you want to keep everything in milliampere, no issue in that. Okay. So, 20 milliampere, Rg 30 ohm, I maximum I that needs to be measured is 3 ampere. So, 3000 minus 20 milliampere for Ig, and S has been asked. So, what is the S value? 600 by 3000 minus 20, it is like 2980, right, something like this, correct. So, now 0 0 cancelled and you have to 230 and this is 2149. So, it is something like 30 upon 149. So, what is the answer? 149. This is the value of x. So, which option is matching? It is the fourth option. Alright everyone. So, let us look at the next question. Massless spring gets elongated by amount x1 under a tension of 5. So, that means 5 is nothing but kx1. Then its elongation is x2 under a tension of 7. That means 7 is kx2. For the elongation of 5x1 minus 2x2, what will be the tension? Well, force will be k times 5x1 minus 2x2. So, this will be 5 times kx1 minus 2 times kx2. 5 times kx1 means 5 into 5 minus 2 into 7. 25 minus 14, which is 11. So, 11 Newton should be my answer over here. So, which option is matching? Second option. Next question. 2-point charges minus 4 microcoulomb and plus 4 microcoulomb constituting an electric dipole are placed at minus 9, 0, 0 and 9, 0, 0. So, the positive charge is at 9 position and minus charge is at the minus 9 position. So, if I take the 2-point charges minus 4 and plus 4 microcoulomb, the distance between them will become how much? 18 centimeter. Okay. This position of it is actually 9, 0, 0 and the position of it is actually minus 9, 0, 0. Now, in a uniform electric field of strength, E is given 10 to the power 4 Newton per coulomb. The work done on the dipole in rotating it from equilibrium through 180 degree. What is the work? What is the potential energy formula, by the way? Minus P dot E minus P E cos theta. So, you go from the change from 0 degree to the 180 degree change, because see they are talking about from the equilibrium position, right. So, I will say that let us say initially what happens, the potential energy is minimum, which is the stable position theta equal to 0 degree. What is the potential energy initial? It is minus P E and then finally it will become 180 degree, U final will become plus P E. So, what is change in potential energy? 2 P E, and from where this change will come? From the work done, correct. So, work done will be then nothing but 2 times dipole moment is, what is dipole moment? Charge into distance. So, how much is charge? 4 into 10 to the power minus 6 and distance is 18 into 10 to the power minus 2 and my electric field is 10 to the power 4. So, this will be in joule, the answer will be in joule. So, how much is work coming in joule now? Let us see 18 into 8 over here, right, that is nothing but 36, 72 into 2, 144. So, 144 into 10 to the power minus 8, 10 to the power minus 4 joule. In millijoule it will become 14.4 millijoule. Alright, so this is going to be the answer for it. Okay. Which option? 14.4 millijoule. I hope it is clear. Let us move to the next one. A plain electromagnetic wave of frequency 20 megahertz travels in free space along the positive x direction. So, it is traveling in the positive x direction and frequency is given 20 megahertz. Okay. At a particular point in space and time, the electric field vector of the wave is given E y 9.3 volt per meter. Then the magnetic field vector of the wave at that point, magnetic field vector will be along which direction? By the way, suppose this is the electric field E y direction, in the y direction, let us take it this x, then this is y, then out of the board will be positive z. So, I know one thing, if I go by this concept, the direction of E cross B vector, I hope you remember, the direction of E cross V vector is the same as the direction of velocity vector. So, in which direction the wave is traveling? In the positive x direction. Okay. And E vector is along j cap. Where should be my B vector? My B vector therefore should be along positive z direction, because then only E cross B will give me the positive x direction. Okay. So, we have to see Bz. Now, Bz is nothing but the formula E y magnitude divided by C, and that is 9.3 divided by 3 into 10 to the power 8. So, this will be 3.1, okay, into 10 to power minus 8 Tesla. That is the answer. So, which option is matching? It is the fourth option. Alright everyone. So, I hope it is clear. Next question. Given below are two statements, one is labeled as assertion and the other is labeled as reason. Assertion: the binding energy per nucleon is found to be practically independent of the atomic number A. For nuclei with mass numbers between 30 and 170, this is pretty much the structure of that graph over here. It starts gets flattened from, let us say, around 30, right, and till 170 it is almost like flat. So, this graph is like binding energy per nucleon and this is the mass number. Okay. So, now you can see that almost it is like same. So, binding energy per nucleon is found to be practically independent of the mass number. For nuclei with mass number between 30 and 170, it is correct, right. So, A is true. Let us talk about now R. Nuclear force is long range. Oh, this is wrong. It is a very short range, right. So, directly it is false. Done. So, which option is correct? A is true and R is false. It is going to be fourth option. Let us move to the next one. Refractive index of internal material of the glass prism is √3. The angle of minimum deviation is equal to the angle of prism and refractive index is √3. So, you need a formula, remember it was the refractive index formula with minimum deviation, sin minimum deviation plus A by 2 divided by sin A by 2. Okay. It comes from the minimum deviation concept, it comes from the concept of I plus E minus A type structure, right. This type of equation will give us the minimum deviation case, and at minimum deviation what happens, my angle of incidence and my angle of emergence both are equal at when deviation is minimum deviation. Okay. So, in that case you can write down your I in terms of minimum deviation and A, and your R1 simultaneously will also become equal to R2, right, at minimum deviation moment, and that if R1 plus R2 by geometry it is A. So, I can write down what will be my R1 equal to R2 equal to, it will become A by 2. So, this is the refractive index formula. So, I think you just need to put down the value. Mu is how much? √3. Okay. Sin of minimum deviation is A, which is A plus A 2A. So, it will be A divided by sin of A by 2. You can again apply trigonometry identity over here, 2 sin A by 2 cos A by 2 divided by sin A by 2. Okay. This is 2 cos A by 2. So, what is cos A by 2? It is √3 by 2, and whose cos is √3 by 2? It is 30 degree. So, therefore, A by 2 is 30 degree. So, A is 60 degree. Okay. I hope it is clear. So, which option is correct? Fourth option is correct. Okay. Let us move to the next one. The energy of system is given as this, where t is time and beta is 0.3 per second. The errors in the measurement of alpha and t are 1.2% and 1.6%. At t equal to 5 second, maximum percentage error in the energy is. Okay. So, my formula is E is alpha cube e to the power minus beta t. Take ln. Ln E is 3 ln A alpha minus beta t. Now, take the differential element. Okay. D of ln E is equal to 3 times d of ln alpha minus beta times dt, correct. But when you are considering the errors, the minus is not involved, it becomes positive. You think about the subtraction case, right, the errors you have to add up always. So, therefore, I will not write down in perspective of with view of errors, this minus will become plus. And what is d of ln E? It is 1 by E. You can multiply and divide by dE. So, it will become 1 by E times dE, and then similarly d of ln alpha, d alpha by alpha plus beta. What are these dE, d alpha and dt? they are just errors in the respective terms. So, this can be think of if you multiply this by 100, that will be percentage error in E, okay? And if you multiply this by 100, it will be percentage error in alpha, and okay, that is how you can proceed. So, let us see what you can get from here. So, percentage error in E is equal to 3 times percentage error in alpha plus beta times, then this is dt only, okay. The t only means the error in t multiplied by 100, that is it. So, what is the percentage error in E? 3 times percentage error in alpha 1.2, beta is 0.3, okay. Then delta t, how to find delta t? Well, delta t by t into 100 is given as 1.6, okay. So, what is the delta t? T is 5. So, delta t is 5 into 1.6, how much is going to be like 116.8, right. So, it will be 8 by 100 or 0.08. So, just put here 0.08 multiplied by 100. So, therefore, you get it as 3 into 1.2 3.6, and then you have 100 8 into 0.3 2.4. How much it is? 3 to 5, 5 plus 1, it will be 6. So, 6 percentage will give me the answer. So, which option? Third option. Alright, let us move to the next one. Water of mass m gram is slowly heated to increase the temperature from T1 to T2. The change in entropy of the water given specific heat of water is 1 joule per kg per Kelvin is. Well, the change in entropy is given as simply the change in if you talk about for the differential element or infinitesimal elements wise, okay, how you should write down properly, the ds is nothing but dq by t, the heat absorption which is taking place at a particular temperature, correct. You should write down dq by t, and then if you want to find total change in entropy, you should integrate this, right. So, what will be the answer? The change in entropy delta S is dq. What is dq? It is slowly heated to increase the temperature from T1 to T2. You will write down m, right, and then S is how much given? 1 joule per kg per Kelvin, right, and but m is in gram. So, you should write down m by 1000 to put it in kg, then you have S, then you have delta t dt, okay, and then divided by t, then you have to integrate. T will go from where? T1 to T2, that is it. What is the integration? M by 1000 ln, okay, how much will it be? Ln t or ln of t limit T1 to T2. So, well, this is going to give you the answer now, m by 1000 ln T2 minus ln T1. So, will give you logarithm property wise ln of T2 by T1. But here one interesting thing is that this 1000 factor is coming, but you are considering SI units with this in that perspective, right, then only it is like this. But if you go by the option wise, right, which option is nearby then? Maybe they are not given the units here, okay. So, it could be any units, but the format should be remain same, okay. So, m ln T2 by T1, which option is going to match then? It will be fourth option, alright, okay. So, I hope it is clear. So, therefore, what will happen? Which option is correct? Fourth option is correct over here. Let us move forward. Match list 1 with list 2. List 1, permeability of free space, magnetic field, magnetic moment, torsional constant, all have some dimension formulas, right. You can pick any of the formulas which are relating with them. So, I will say that you can take a formula, let us say magnetic field, when you write down, it is something like mu naught I by 2r of that circular ring around it, about its center, right. So, what should be the mu naught? It will be Br by I, okay, 2 Br by I. So, when you talk about dimension formula of B, well, you can take help of the equation that my E by C is B, and then what is E? E is actually, or you can take QVB formula also as a force. So, we will go by that then, okay. So, what is the formula of this force, magnetic force QVB. So, my B formula can be used as force by charge into velocity. So, something like this I can now get the dimension formula of B. It is the dimension formula of F, which is ml t minus 2. Charge is current into time, right. So, ampere t, then velocity is Lt minus 1. So, how much do we get here at the end? This is L cancel, this is t to the power minus 1 to the t to the power minus 2 m a minus 1 t to the power how much t power minus 2. This is my B. So, dimension formula of mu naught will be how much? Dimension formula of B, dimension formula of the r, which is distance, and dimension formula of the current, which is A. So, overall it is m l t minus 2 a to the power minus 2. Okay. So, m l t minus 2 a to the power minus 2. So, which option? For A option, the matching will be with this 3. Okay. The next one is the magnetic field. Just now we have found it is m t minus 2 a to the power minus 1. So, magnetic field will match with m t to the power minus 2 a to the power minus 1, this option, right. Next one is magnetic moment. Magnetic moment is described like how? It is actually nothing but current into area, and current is A and area is L2. So, L2 into A. So, which option is matching with magnetic moment? It is 4th, and hence the remaining one will be the D option, torsional constant. So, D option, torsional constant, we can use torque equation. Torque by theta is my torsional constant, and therefore, I can write down this dimension formula of torsional constant will be the dimension formula of torque only. Theta has no dimension, right. So, torque dimension is ml, just like force into distance, ml to t minus 2. Okay, clear. So, which option is matching? It is going to be the, with the D option, it is the first option. Okay. So, here we go. Now, which option of this is correct? With A we have 3. Okay, it is the only one option, right. You can directly would have ticked and save your time. Next question. Water flows in horizontal pipe whose one end is closed with a valve. The reading of the pressure gauge attached to the pipe is P1. Okay. You see, if the pipe is closed from one end, what is the pressure that they are reporting? P1. It is closed, but when it is open, right, it will move with some velocity v, correct. And what is the pressure? P2. Well, simply you can apply what between two scenarios, Bernoulli's principle, right, correct. So, what is that Bernoulli's principle going to give you? P1, there is no potential energy, there is no kinetic energy, and then after the removing there is a potential energy, right. No, sorry, okay, only kinetic energy, half rho v square. So, what is your v? It will become 2 times P1 minus P2 divided by rho, its root. So, it is proportional to root over 2 times P1 minus P2, which is nothing but root over P1 minus P2. Okay, so, second option is the correct answer. Let us move to the next one. A ball having kinetic energy k is projected at an angle 60 degree. So, it will go and then what will be the kinetic energy of ball at highest point, alright. So, let us say speed here is u, highest point will be u cos 60 left only, the horizontal one. So, what is the kinetic energy at this moment? Half m u square cos square 60 is 1 by 4, and what is the kinetic energy here? Half m u square. Okay. So, then they are asking that they have said that this is actually k e and this is something, right, we do not know, k e prime. So, what will be the kinetic energy of ball at highest point? K e prime in terms of k e, this is k e. So, it is nothing but k e by 4 over here, that is it. So, which option is matching? Fourth option. I hope it is clear. Let us move to the next one. the width of one of the two slit in YDSC is d, while that of the other slit is, actually it is given as xd. Okay, I will just put it here, xd. If the ratio of maximum to minimum intensity in the interference pattern on the screen is 9:4, maximum intensity formula, remember, root I1 plus root I2 whole square, and minimum root I1 minus root I2 whole square. Okay, right. This ratio is given as 9/4. So, let us move forward. They are asking about find the value of, what is the value of x, what is the value of x over here. Okay. So, how to do it? Very simple, and we know that in this given in the question, by the way, look at the bracket term, this is very important. Assume that field strength, that is the amplitude, is actually depending on slit width over here, correct. So, what we will assume that my amplitude is proportional to the slit width. So, obviously, then intensity, which is proportional to the amplitude square, it is telling me it is proportional to the d square, or my slit width is proportional to root over I, right, like this. So, very simple, I can write down root I1 there at that place, I can write down d1 at root I2 d2 divided by d1 minus d2, its whole square is 9/4. What is d1? It is actually d, and what is d2? xd. So, this will be how much? D plus xd, okay, divided by, since it is a square, you should consider it as a positive after squaring it. So, better to write down positively, right. Instead of writing d1 minus d2, you can write down d2 minus d1 also over here. Okay. So, I will write down xd minus d, that thing will become, this will become 3/2. Let us solve it. 2d plus 2xd is 3xd minus 3d. Now, d will cancel. So, what is this going to give you? 3x minus 2x is x, 2 plus 3 is 5. So, what is the value of x finally coming out? It is 5, which is which option? Fourth option. I hope it is clear. Let us move to the next one. If a satellite orbiting the earth is 9 times closer to the earth than the moon, what is the time period of rotation of satellite? Given rotational time period of moon is 27 days, and gravitational attraction between the satellite and the moon is neglected. So, it is related to the Kepler's law of periods actually, where we say that my time period square is proportional to the r cube. R is changing, time period will change, right. So, I can simply write down, they are asking about the final, the time period, right, of that satellite. So, I will write down T2 by T1 is R2 by R1 power 3/2. Okay. So, what is my T2? 27 is the time period for the moon. T1, T1 is given as 27 days, and there is something R1 for it, but what about R2? R2 is what? It is actually R1 by 9. Okay. So, what is R2 by R1 then? R2 by R1 will be 9, 1 by 9, 1 by 9 to the power 3/2. Take the root, it is 1 by 3, then take the cube, it will be 27. So, 27 by 27, that is 1. So, it will be 1 day. So, which option is correct? Third option. I hope it is clear, right. Let us move to the next question. Circular disc of radius r and mass m is rotating around the axis perpendicular to the disc. Okay. An external torque is applied to the disc such that theta is given. Okay. So, theta is given function of time, where theta is the angular position of the rotating disc at function of time. How much power is delivered by the applied torque when t is 2 seconds? What is the formula of power? It is tau dot omega, and we assume that theta is 0 degree, cos 0 is 1 here, as it is given that the torque and omega both are in same direction, right. And then what to do? Torque you have to find. What is omega? D theta by dt. It will be 10t minus 8. So, how much is omega at t equal to 2? 20 minus 8 is 12. What about the torque? Torque is well, I into alpha. Well, for that, what is I? M r square by 2 for the disc. Okay, this is for the disc. What about alpha? D omega by dt. How much is d omega by dt? It is going to be 10. So, what is the torque? Torque is mr square by 2 into 10. Okay, so what should be the power? The power will be tau dot omega. Omega is 12. Okay, now you simplify it. 60 mr square should be the power applied. Okay, so which option is matching? Second option. I hope it's clear, right? Let's move to the next section of it, the last 5 integer based questions. An air bubble of radius 1 millimeter is observed at a depth of 20 centimeter below the free surface of a liquid having surface tension this and density this, 10 to the power 3 kg per meter cube. The difference between pressure inside the bubble and atmospheric pressure. Well, you have a bubble where at a depth. So, what should be the pressure inside? Well, whatever be the pressure at this position is, let us say, P out. And what is P out, by the way? It is at a depth of some h, outside is P naught. So, I will write down P naught plus rho g h. Then what is P inside? As per excess pressure concept, P inside is P out plus 2 T by R. Okay. And therefore, this will become P naught plus rho g h plus 2 T by R. Now, they are asking difference between inside pressure and atmospheric pressure. So, P in minus P O, right, P naught, which is rho g h plus 2 T by R. Let us substitute the numbers and we will get the answer then. Let us find it out. Rho is 10 to the power 3, g is 10 and the depth is 20 centimeter plus 2 times surface tension 0.095 divided by radius 10 to the power minus 3. So, this number is coming out how much? This is like 110, 2000 plus, okay, 2 into 95, 95 2 ja 190. So, it is like 2190, okay, and well, in SI unit it will come, okay, Pascal, because everything we have put here in SI units. So, this is my answer, right. So, the integer will become 2190 for it. All right. Let us move to the next one. At steady state, the charge on the capacitor as shown. At steady state, how capacitor behaves? It behaves like a broken wire, right? Behaves like broken wire. So, can you draw the circuit once again? Yes, it will look like this. This is 10 ohm, this is 15 ohm, this is 5 volt. So, what is the current flowing through it? 5 by resistance 25. So, this is 1 by 5 ampere. Now, if I talk about what is the potential difference between A and B. So, VA minus VB will be current into resistance, which is 2 volt. That means, if I have capacitor plates here, the potential difference is 2 volt. So, what is the charge? Charge is CV. C is how much? C is given as 8 microfarad and voltage is 2. So, overall answer is 16 microcoulomb. How much it will be? 16 microcoulomb. Okay. So, what is the correct answer then as an integer? 16. All right. Let us move forward. A satellite of mass m by 2 is revolving around Earth in a circular orbit at a height of r by 3. Okay. So, it is at a height of r by 3. All right, mass is m by 2. This height is r by 3. So, from center this is r. So, total distance can be think of it how much? 4 r by 3. Okay. Now, it is revolving around Earth in a circular orbit. What about the velocity, orbital velocity then? See here, first thing is very interesting that we might be ignoring if I do it in fast, right, is that both the masses are comparable. One is m and one is m by 2. So, they should be moving around their center of mass if you want to get correct answer exactly, correct. But I think while framing the question, this thing might have been ignored. So, we will do it from the both angles. Once the angle is that we will keep earth at rest, and the other angle will be that earth and the satellite are moving around their center of mass. Okay. So, from the first case it will be earth is at rest. Let us see the answer from this perspective. Okay. So, orbital velocity, then in that case we have seen in the classes or in books also that the formula becomes root g m by r, right, root g m by r. What is r? 4 r by 3. Okay. And we know angular momentum will be then nothing but the mass which is moving m by 2, the orbital velocity, and what distance it is? 4 r by 3. So, what is this becoming? M is going to be m by 2 m by 3 r root over 3 g m by 4 r. Now, take r inside and 2 by 3 also inside. So, m into this will be like 4 by 9, right. So, it is like 1 by 3, correct. R is there, right. So, it will be r g m by 3. All right. So, in that scenario, what is the answer coming in terms of at the position of x? The answer is x equal to 3 in that case as per the first case. The second case that I should take is that they are moving around their center of mass. Okay. Now, if they move around their center of mass, then consider it as some point masses objects. Okay. So, I will take one is m and one is m by 2. The center of mass will be here somewhere, right, and then by the help of concept wise, this is let us say r 1, this is r 2. Okay. How much is r 1? R 1 is going to be m 2 r by m 1 plus m 2. What is this r? 4 r by 3. So, I will write it down as m by 2 4 r by 3 by total mass 3 m by 2. How much it is going to be? It is going to be 4 r by 9. Similarly, what is r 2? M 4 r by 3 divided by 3 m by 2. So, this is going to be how much? 8 r by 9. Okay, so, you got the r 2, you got the r 1 now. Now, they are moving around the center of mass with some omega like this, correct. And how do you write down angular momentum in that scenario? It is I omega. What is mass? M by 2. The distance is r 2, correct, and r 2 is how much? R 2 is going to be given as over here 8 r by 9. So, I will write down r 2 ka square into omega, and then the question arises how to find omega, right. Well, you can apply the Newton's laws of motion, okay, which in that perspective you can apply the centripetal force conditions, and then you can get the omega from there. Okay. So, we will do it, right. I will do it somewhere over here, have a look at it. Okay. So, when I talk about this thing, what is the force of attraction? G m by 2 into 4 r by 3 ka whole square. So, this will be 16 r square into 9, and that should be your m v square by r or m r omega square, right, centripetal force. If you take v square by r, it is same as m r omega square over there. So, it will be m by 2 r. What is that r? Which r you have to take? R 2, which is nothing but r 2 is 8 r by 9 into omega square, right. Can you find omega from here? Yes. So, here the function will become like this. How much is the omega coming up now? 2 1 ja, 2 4 ja, this 16 2 ja, that is going to be 81, right. So, overall it will be 81 divided by 4, 4 2 ja 8, 16 into 4, 64 into 2 is simply the 128. Okay. So, 128 over here, right, 81 by 128, this factor will come, and then 1 m and 1 m will cancel, right. What else is left? The r will be there in the denominator, okay. It will be r cube, right. Anything else? It is g m also in the numerator, and then take the root of it. So, let us find out L then. In the second case, the L will be m by 2 r 2 square. What is r 2 square? 16, 8 8 ja 64, 64 r square by 81, okay. Then take omega root over 81 by 128 into g m by r cube. If you simplify it, take m outside only, right, and take the other things inside of the root. How much do you get? 81 ka square, 81 will be left denominator, and 64 ka square will be there inside. So, that is what you will get, 64 2, right, 4, 32 by 4 8. So, overall it will be 8 by 81, correct, 8 by 81 GM R. So, as per this perspective, what is my x value coming? 81 by 8, which is approximately 10. So, there can be two solutions of it, right. From the second case, it is coming out to be 10. I hope it is clear, right. Let us move forward to the next question. A time varying potential difference applied between the plates of parallel plate capacitor of capacitance 2.5 microfarad, and we have a dielectric constant of the medium between capacitor is 1, which is like air, right. It produces an instantaneous displacement current of 0.25 milliampere in the intervening space between the capacitor plates. The magnitude of the rate of change of potential difference will be, well, it is related, the concept is coming from the displacement current, right. You have the parallel plate capacitor and we have a potential difference. The potential difference is changing with time. So, what will happen? The charge on this plate is also be function of time, right, and when charge will be function of time, the electric field here will also be function of time, and when electric field is there, a flux of electric field changes, we have the concept of displacement current, right, and then you simply write down your displacement current as epsilon naught d phi by dt, right, and if you substitute here, what is the electric flux? E into area, right. So, it will be epsilon naught A d by dt. What is electric field? It is the delta V by the distance between them, plate distance is let us say d. So, you will write down V by d, d is constant, but V is function of time. So, it will become epsilon naught A by d dV by dt. Now, the displacement current is given as 0.25 milliampere into 10 to the power minus 3. Now, epsilon naught A by d is what? It is the capacitance, which is 2.5 microfarad, okay, and dV by dt is something we have to find. So, what is the answer coming? dV by dt now. It is going to be, this is like 0.25 into 10 to the power minus 3, 2.5 into 10 to the power minus 6, okay. This will be 1 ja 10, 10 to the power minus 5, 5 by 3, 10 to the power 2. So, what is this answer? It is going to be 100 volt per second. So, what is the integer answer of it? 100. All right. I hope it is clear, right. So, let us move forward now. Let us have a look at this last question. In a series LCR circuit, resistance is given 300 ohm, capacitance is given 25 nanofarad, and inductance is 100 millihenry. For maximum current in the circuit, the angular frequency of the AC source is that particular quantity, something let us say x, okay, x into 10 to the power 4 radian per second. You have to tell the value of x over there, okay. Let us see. So, maximum current, when do we have maximum current? When the frequency omega is actually 1 by root LC, right. So, omega will be then 1 by root LC in the resonance condition. I hope you remember, right, resonance condition. So, this is nothing but 1 by root over L, L is 25, this is 100 millihenry. So, 100 into 10 to the power minus 3, and C is 25 nanofarad, 25 into 10 to the power minus 9. Okay. If you simplify it, then what is this? This 25 root is 1 by 5, and 10 to power, how much is 10 to power here in the root, in the denominator? 10 to the power minus 1, 10 to the power minus 10, 10 to the power 5. in the numerator it will come then. Okay. So, 10 to power 2 you can take out 10 you can take out 10 by 5 into 10 to power 4. So, this is 2 into 10 to power 4, correct, and therefore, what is your answer then? If you compare with the question, it will be 2. Okay, so this is all about this paper which was held in the evening session on 23rd of January 2025. All right, I hope it's clear. Thank you so much.